My name is Vladimir Kovalenko, and I lead the Intelligent Collaboration Tools Lab. Our main focus is making the collaboration tools in software engineering mostly smarter through data analysis and through data-driven features. We were established late last year, 2020, so we are just under 1 year old by now. And we pretty much spun off another lab, the ML4C lab, where I was working as a senior researcher, and at some point got to lead a few projects of my own, which were a bit beside the lab's main interests. So that's how we came to be an independent lab. It's not just one project, it's rather a set of interests, a direction that I was interested in particularly. And also I think it's objectively underrepresented in the research community. So if you look at software engineering research, at the whole field of software engineering research, a great deal of research works are dedicated to building methods for more efficient processes and tools. You can think of problems like defect prediction or duplicate issues detection or whatnot. So these problems have been around for quite a while now. And if you try to classify all those problems between different contexts, different tools that software engineers use and other people use in software engineering, you will find that most of them are dedicated to working with code. So it's code completion, it's test generation and whatnot. So it's about helping people write or edit code or comprehend code. At the same time, if you look at the research which studied what software engineers actually do at work, you'll see that at best, on average, a software engineer writes code for like half of their work time, usually less, on average less. And most of the rest of the time is spent on collaborating with others through a different set of tools. It can be just an email or a messenger, but it also could be code review tools, issue tracking tools, continuous integration tools. So many collaborative processes like data sharing and keeping each other aware and syncing and coordinating on tasks is supported with dedicated tools. But those tools are a bit less popular as a research context. So if you exaggerate a bit, if I can exaggerate a bit, an IDE is really smart. So it's really complex. It has a lot of technical complexity inside to be able to support the daily tasks of engineers when they work with code. But if you look at collaboration tools, they are not as smart, not remotely as smart. So again, exaggerating, they're similar to an internet forum or something like that in complexity, in the level of modeling the processes behind them. And we're trying to change that. Speaking of the scientific achievements and the scientific events of my colleagues and myself, this year was not very busy in sense of interacting with the community because we still don't have physical conferences, unfortunately, though we tried to go to one, but it got cancelled. We did a lot to establish our processes. We finished a few projects that our lab started with. And we grew a bit. So speaking of the projects, one of the most exciting to me is the buzz factor analysis. So if you've heard of buzz factor, it's like a half-joking notion of the project's stability in terms of people turnover. So if one person knows everything and other people know little, then that person is kind of indispensable. If they get hit by a bus, then project might be dead just because no one knows what's going on. So that kind of a team would have a buzz factor of 1. And this is something that you can actually estimate automatically through the tools. And researchers have been doing it before us, at least for like the last 10 years. There exist models that have been checked in practice. They work more or less well. But the problem is they only rely on code. So they look at the collaboration of people on code, which is, again, not the only channel of collaboration, of communication, not the only channel through which knowledge transfers between people. This year, we've built a model to estimate the buzz factor of a team, including data other than collaboration and code, such as collaboration code reviews and so on. And we strongly believe that it works better than the previous models. Also, one thing I need to mention here about these buzz factors, so we also did a study of perception of importance of the problem among just developers. So we got quite a few responses, and we have proven the importance of this problem to ourselves and to others. So this is also a big deal. We figured that it's an important thing for developers. This project and one more project that I wouldn't probably speak so much in detail about were our collaborations with the university in Turkey. So we've had through 2 interns from Turkey working with us this summer. So we had a really distributed team, and it was an amazing experience. It was a bit challenging for everyone in the team, I think, because we had to switch to English. So we were actually, through the summer, none of us spoke their native tongue to each other. But it was a good experience, and I think I would like us to continue working with people from all around the world from now on. Working in a growing team, in a new team, and in an international team, also in those uncertain times, so to say. It was a big challenge to me because even though I'm used to working in international teams, I'm fine with speaking English at work, but still it was my first experience. So there are some things that you just cannot imagine that you'll have to care about. So of course it was a fruitful period in terms of growth. So I had to learn to deal with all the everything that leading a lab involves, and I think we're doing quite well here. I wouldn't say our vision changed that much, but again, we learned a few things that work for us and that don't, like the way it's more convenient for us to plan the work, the pace we take, because there is a difference between working at just 1 project at a time and say 3 at a time, right? It's different for everyone involved. So some of those things we know we were gonna be doing in the future, and some we decided not to. Also, I feel like in research, in academic research groups especially, people often underestimate the importance of technical work. So there is this common notion of the academic code that is written once and has to be thrown away after the review. Well, I'm exaggerating again, but still, it's a big issue that it also impacts the reproducibility of research and the efficiency of the whole machine. So I think that we will have to put more emphasis on the technical deliverables. We'll have to put extra effort into making sure the open source software we release is actually usable and reusable, that our experiments are reproducible, that we share all the data that we can share realistically. So this is something that I feel is more important now than I felt it is important a year ago. And this, of course, is going to shape the way we work next year. If I had to summarize our plans and our vision for next year, I would love us to continue to grow sustainably.